Time for me to start. Good morning, everybody. Thank you for coming out on this winter morning. I should keep my mouth shut with the lucky winter. I got to spend some quality time with my snowblower this morning. Where I live, we got a lot more snow than out here, but still, it's not that bad. All right, a couple quick things from the management. First of all, let me remind you, this Thursday will be test number 2. Test number 2, as I have here, is 9 pages, 10 problems. Some of the problems are multiple parts. They'll cover alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. Points breakdown, general knowledge, 11 points, nomenclature, which you know the 2 types of questions. There's structure, did the UPAC name. Here's the name of the structure, dry. And then reactions, give the product or products of the following. And I have under there 3 synthesis problems. Only 3, because any more would be cruel and unusual punishment. And it's outlawed by the Supreme Court, at least up to now. And that is give the starting materials for the following. And adds up to 105, so that means there's 5 bonus points. And any questions? Our coming events this week. Tomorrow I'll do a review. Wednesday we'll get back to carboxylic acid, which will not be on test 2, it'll be on test 3. And then Thursday I will be giving test number 2. And it looks like the weather, keep my mouth shut. So anyways, the weather looks like no problems on Thursday. So, any questions? All right, before I go on any further, I'd like to thank each and every one of you. Last week, Tuesday and Thursday, you nitrated bromobenzene. That's an extremely dangerous lab. Use both nitric and sulfuric acid. Everybody did it correctly. Thank you. And thank you too. Speaking about labs, for this week's lab, the to-do list is pretty short. Just in part B and C, I think it is, in 6 test tubes for part B, with this and this and this, and these chemicals and observe for, that's 1. Part C, in 6 test tubes for 5, put this, this, and this, with this, this, and this, mix and observe for, and that's it. So, a couple lines, you don't have to do 20 pages. All right, as promised, I will be going through the ketones and aldehydes problem set. As one of your colleagues pointed out, there are 1 or 2 errors in here. One of these decades, I'll change it and fix it. But to see an error, that's possible, because last time I checked, I don't walk on water unless it's frozen. Even then, I stay off. All right, you know the drill. Also this weekend, no, I didn't have any miracles. So make sure you enunciate loudly what letter you like, because that's probably the hardest thing for me to hear. All right, first one. Oh, before I do that, I almost forgot with the snow. Did anybody happen to drive by a gas station and think they have ethanol in there, and that's an alcohol? Would you pick up a bottle of rubbing alcohol and see under isopropyl alcohol, which is a alcohol and rubbing alcohol? Or if you look at the type of nail polish remover you use, does it have acetone in there, which is a ketone? Think about those things, it won't hurt. All right, let's get going. A, B, or C, give the IUPAC name for the following. Anybody have a question on A, B, or C? All right, well in that case, I'm not going to do it. Can you do C? I'll just say I'm going to do C. So let's do it. First of all, what are we looking for? What's different? What's not carbon or hydrogen? You see an element that's not carbon or hydrogen, should get your attention like that. Oxygen don't bond to carbon. Carbon's there, carbon's there. It's a ketone. Ketone. And how do we do a ketone? Find the longest chain? Oh no, it's a ring. Find a ring. How many carbons? How many bends? 6. Hexane. Ring. Cyclohexane. Remember, common mistake on test, students forget to put the cyclo. I mark it totally wrong. Don't forget to do that. Cyclohexane. It's a ketone. drop the E, add O-N-E. In a ring, you don't, unlike a acyclic compound, you don't need a number because the carbonyl-carbon is always one. And then, so it's cyclohexanone, we have a methyl group, isopropyl group, 1, 2, 3 methyl, 4 isopropyl. On the test, you put 4 isopropyl, 3 methyl, I would mark it correct because I'm not only using that alphabet. All right, D, E, or F. Anybody have a question? Well, in that case, I'm going to do D. I'm going to move for D. All right, let's look at D, once I get this out of the way, and say what's different. Oxygen, double bond to carbon. And notice that carbon, which is the carbonyl carbon, remember, carbonyl group. Carbon, double bond to oxygen. We have a carbonyl, carbon double bond to oxygen. It's got a hydrogen, R groups. And that's an aldehyde. How do you do an aldehyde? You find the longest chain that contains the carbonyl carbon, carbon double bond to oxygen, and you name that as an alkane, 7 carbons, hexane. It's an aldehyde. You drop the E at the end of hexane and put Al. Make sure on test you do your Al and OL clearly, because OL, alcohol, Al, aldehyde. And so 7 carbons, heptane, drop the E, add Al, heptanal, and now what do we have left over? Oh, a methyl group and a methyl group, you know those. And we have 2 of them, dimethyl, that are on carbons 3 and 5. And let's do F while we're in the neighborhood. And F, what's different? Carbon double bond to oxygen. Carbonyl. It's got carbons on one side, carbons on the other. It's a ketone. What's the longest chain? With this carbonyl carbon in it, 9. And therefore that's no name. Drop the E, add O-N-E, known. And then what carbon is it on? You start from the end numbering always. 1, 2, 3, that always gets the lowest number. So it's 3 known and known. We have an isopropyl group on carbon 6, so that's how you do it. And before I forget, for my videotaping, that helps me when I'm processing. By the way, I'm caught up to date, and by tomorrow evening, if all goes well, I should have today and tomorrow's lecture, so everything for test number 1 will be online by sometime tomorrow evening. And if you've noticed, at least I've noticed, since I changed some of the properties when I process the video, they seem a little clearer and you can read the board better. And don't forget to join the Dr. White fan club. All right, let's go to problem 2. That went over like a lead balloon. Boy, I just did a generation gap on you. When I was a kid, if something didn't work that you thought would be funny, you'd say, ooh, that went over like a lead balloon. Or you'd say, that's as funny as a screen door in a submarine. Think about it. Anyways, all right, let's look at number 2, the other type I have nomenclature question. Draw the condensed structures for the following. And here I include both common and IUPAC names. Anybody have a favorite? A, B, or C, D, E, F, or G? All right, in that case, Dr. White's going to pick on Snowy Monday. And let's look at D. D is formaldehyde. That's the simplest aldehyde when R is a hydrogen, and therefore there are 2 ways to writing it. Also, let's look at F. What do we have? How do we decode this? You start here, go this way, Al ending, aldehyde. If this were an E, decane, 10 carbons. You can start from either side. We either start here, I'm going to start from the right. Carbon number 1 is my aldehyde, carbonyl, hydrogen. I'm getting all choked up over this aldehyde. And 10 carbons. What do we have next? N-propyl, that's a mistake. Oh no. See what a snowstorm does to you? N-propyl, and if that were erased, it would be that, and then 2-methyl, I got that one right. So make sure you change that. This should not be here, and that's an N-propyl group, and this should be CH2, and it should be like that. And that's how you do that one. Let's see if I made any more mistakes. I know I did. Hopefully not on this page. Well, there goes my perfect score. Let's look at G. How do you decode it to know what to draw? You start all the way from this end and you go this way. O-N-E-N-D, ketone. If this were an E, no name, 9 carbons. I have 9 carbons. Where is the carbonyl carbon of the ketone? Carbon double bond to oxygen, carbon 3. I've got that. Next I have on carbon 5, at least I got it right this time, isopropyl, carbon 2, methyl, and that's how you do it. And those are 2 types of nomenclature questions. All right, A, B, C, or D. Does anybody have a favorite? Question is, give the organic product or products for the following. And let's do C. And the question is, if I take this and react it with an O in a bracket, that means oxidizing agent. What do you get? And if you notice, I have here what's different. Carbon with hydroxyl, carbon there, secondary alcohol. When you oxidize it, you move these 2 hydrogens and form a carbon-oxygen double bond. Do you break carbon-carbon single bonds? No, so I don't. And therefore, all you're going to do is remove those 2 hydrogens, and that carbon form a carbon-oxygen double bond. You go up or down, and I have it down. You can just easily put it going up, and everything else stays the same. And once again, I'm inoculating you to the organic instructor's favorite trick on a test, and that's use scary R groups. Yes, Lisa?
I just have a question. Why wouldn't you break down, like how you did with A, how it became OH? Why is it double O? Like,
Let's see.
why is it like that, where it like that?
Hi, that could be a double bond, yeah. Don't I have it there? Let's see. All right, first of all, whenever you oxidize a primary or secondary carbon, alcohol, you should always get a carbon-oxygen double bond. No. And if you look at A on your paper, you've got it drawn wrong. That's why. See how you have an extra hydrogen, no double bond there? Where I do. You lose hydrogen there, and you get a carbon-oxygen double bond. That's what happens with a primary, secondary. Tertiary is no reaction, but I'll never put that on my test because I don't feel it's fair to say give the product or products when the answer is no reaction.
But why wouldn't you add an H on letter C, that one?
On which one?
C, why wouldn't you add an
I mean
H?
C, why isn't there an H there? Let's find out. How many bonds to carbon? 4. Let's, ooh, there's even an arrow pointing to that carbon. Am I good or am I good? All right, 1, 2, plus 2 more is 4. 4 minus 4, hopefully it's still 0, and that's why there are no hydrogens on that carbon, because there's 4 bonds to carbon. Oh, that reminds me. I've already said 1, but let's do both of them. What are important things you should always remember for test number 2, 3, 4, and the final, and then be an organic? 1, There's always 4 bonds to carbon. I can do it both hands at the same time, in my coordinator and not. And also, do you break carbon-carbon single bonds? No. But that's how you answer your question. That's a good question, thank you. Because now you won't make that mistake on test number 2 or anybody else, which is a good thing. All right, let's move on because I've got a lot to cover. Notice there are a lot of reactions. Let's look at E and F and G. And the question is, give the organic product or products. Anybody have a favorite? Going once?
G.
Going twice? All right, let's do F. And if I look at F, right here in front of me, I say, what's different? And I have a benzene ring. What else do I have? Carbon. Ooh, carbonyl, halogen, carbon. This is an acid chloride. I also have aluminum trichloride. And what do I get? An aromatic ketone. Let me finish this one. Look out, I've learned names now. I use them too. But anyways, what happens? You form an aromatic ketone where one R group, R prime, is a benzene ring. The other is the R group from here, and it's T-butyl, and that's the product you have. And you have a question.
Could you do G?
Which one?
G.
G like in
Goat.
go. Okay. Or other things like, it's a goal. All right. Ooh, this is interesting, which is why I put it down there. What do we have? And I think I did this in class too, but let's go through it again. Benzene ring. What do I have? Ooh, another benzene ring. But do you know the reaction of a benzene ring with itself? I don't. And, ooh, carbonyl chlorine. Ah, there you are. One of these days they're going to invent a eraserless board. All I got to do is push the button and it cleans itself. Nope, not today. I'm going to call that benzene ring R. Because it's not going to react, it's just coming along for the ride. Carbonyl chlorine, aluminum trichloride. What happens? Friedel-Crafts acylation. You have a ketone. One of the R groups is a benzene ring. Then the carbonyl. And then the other R, this R group. What's R? Benzene ring. And therefore you get this product, and that's how it works. And this one I think I mentioned in class. It's called benzophenone. For many years it was the key molecule used in sunscreens and suntan lotions to protect your skin from UV radiation. They found out it possibly might have some harmful effects. So if you put a methyl group on one of the benzene rings, it doesn't have as harmful effects. And that's it. That helped? Thank you for your question. All right, let's look at H and 3 and 4A. And both are same question. Give the organic products for the following. Let's take a look at H. If we look at H, what's different? We have, carbon, double bond to oxygen. Carbonyl. What else do we have that's different? Alcohol, carbon, hydroxyl. We're reacting with H+. This is one way of writing it. I could have also written it this way. Either one means you take this, reacting together. What is the general reaction? Ketone or aldehyde, in this case R prime is H, aldehyde, alcohol, acid, you get a hemiacetal, ketone. Keep your eye on the carbonyl carbons, because that's where the fun is. And that becomes this carbon. What's attached to it? H and R double prime, methyl and hydrogen, still attached to it. Hydroxyl group, oxygen. Then the R group, ethyl is on that oxygen. Whatever carbon this hydroxyl group is on is the carbon that will be on. And that's how you do it. Let's move on to B and C. Any takers? Which one?
B.
Let's move it down because I can't stretch my arm. And what's different here? Carbon, double bond oxygen, ketone. What do we have? Ooh, 2 or something. That's different. What's different here? Oxygen, hydroxyl group on a carbon, alcohol, acid catalyst. Now, when you have a ketone or aldehyde, this is a ketone, I can say these 2 carbons are our prime, these 2 are our double prime, they're connected together in a ring. What it really tells you is, keep your eye on the carbonyl carbon. Whatever happens, what's attached to it is still attached to it, which means this ring is still there. Which is the carbon? I drew it in so you can keep an eye on it. There, what happens? That carbon has 2 oxygens, and then each oxygen gets the R group from the alcohol. Which carbon is the alcohol hydroxyl group on? The center of 3 carbons. So center of 3 carbons, and you now have this impressive looking molecule. Doesn't that look like some sort of weird creature from outer space? Never mind. But anyways, it's an organic molecule, and that's how you do it. And if you notice here, I have the same thing on C, but now you have to remember something. If you don't know reaction for something, that means nothing's going to happen. So here I have benzaldehyde. Remember, you all smelled it, what was it, 2 weeks ago, the cherry or almond smell. And you're reacting it with what? 2 molecules of ethanol and acid. Do you know reaction of a benzene ring with an alcohol and acid? No, I don't. So this is the R double prime, hydrogen, aldehyde, 2 molecules of alcohol. Whatever attached to carbonyl carbon is still attached. Benzene ring and hydrogen, 2 oxygens, and then my 2 R groups ethyl. And that's how you do it. Now, let's look at D and E. What's happening? What's different? Let's do E, because someone wants me to do the other one. And here, what do we have that's different? Carbon with 2 oxygens to the same carbon. That's rare. There are only 2 cases I know of that. In this case, on each oxygen, I have carbons. They're the same, R. And the carbon with 2 oxygens, I have carbons. I'll call this R prime, R double prime. It doesn't matter which one you designate R prime and R in this class. And therefore, what do you get back? You get back when you use acid and water, acid hydrolysis. We'll learn later on this reaction is going on your stomach. Right now, if you had any carbohydrates for breakfast, it's doing it right in here. I did, so obviously it's going on right here. And what happens, you break it down to get back the original ketone or aldehyde you would have used to make that, acetal, ketal, and the alcohol you would have. And here, what's the R prime methyl, R double prime, attached to carbonyl carbon? What's the R ethyl? I think I did underneath it. Normally, I even put the 2 there for those who like to balance things. And F is the same reaction. And don't forget, if I pass a reaction you want me to go over, just raise your hand, because I haven't said this in a long time, but I've been practicing it and keeping my word all semester. In my class and outside the class, there's no such thing as a dumb question. All right, let's take a look at A or B or C. Does anybody have a favorite? One of these days, well, you already did a couple today. I think you already hit your max. No, there's no max. All right, let's look at A. Which one?
C.
C. All right, question is, what's the organic product or product? And the first question you have to answer is, one way of saying it, what functional group am I dealing with? What's different? Oxygen, double bond to carbon. Carbon's here and here. Ketone, hydrogen and catalyst. Well, you know, carbonyl, one pi bond and one sigma bond with hydrogen. You know, you can break a pi bond like that. And what happens? Take a ketone or aldehyde, when R prime is H, it's an aldehyde, react it with hydrogen and catalyst, you break the pi bond, each atom of that double bond gets a hydrogen, and everything else is still attached, and you make an alcohol. So if we look at here, here's our carbon, here's our oxygen. If I break the pi bond, what happens? Each one gets a hydrogen. You break the ring? No. It's still attached. On a ring, you don't show hydrogen, but on the oxygen, you do. Now, let's see if I was lying to you. I might have. How many hydrogens on that carbon? Let's count bonds. 1, 2, 3, 4. 4 minus 4 is 0. How many hydrogens on that carbon? 1, 2, 3. 4 minus 3, 1. So the hydrogen's there, we just don't show it. And I think that's where you might have had a little difficulty. All right, other questions on that one? All right, let's look at D, E, or F. Anybody have a favorite? Now let's do E. And the question is, what's the organic product or products? And here, what do we have that's different? Carbon, double bond to oxygen, has a hydrogen, carbons. It's an aldehyde. What am I reacting with? Lithium aluminum hydride, first step, second step, acid and water. And it does just like hydrogenation. You break the pi bond of the carbonyl, and each atom gets a hydrogen. But lithium aluminum hydride will only react with carbonyls, not carbon-carbon double bonds, and that's the utility of it, why it's very useful. So to break carbon-carbon single bonds, that's an awful hydrogen, but it's a hydrogen. What's attached to it, R prime and R double prime, still attached. You break the pi bond, and it's that, ethanol, or you can write it that way. Either one are correct. Now, as I look at the problem set, I realize I've made a major omission. So let's do something, because you people haven't had a chance to do something fun yet. So the question is, what would be the organic product or products for the following? Don't forget, tomorrow, the world-famous review for the next test. I don't know if it's world-famous, but it will be the review for the next test. I'm thinking about it. It happened last week, and I think it was last week someone found about it. In the second drawer down here, for many years, I have hidden a big pile of paper towels. If you ever spill anything, like your coffee or tea or whatever, there's something there to wipe it up. All right, time's up. You should have. What's different? Ooh, halogen on a carbon. It's chlorine. What am I reacting with? Magnesium. What do you get? A Grignard reagent. Remember, X can be chlorine, bromine, or iodine. I've never seen it with fluorine. Remember, carbon bonds to magnesium, bonds to the halogen. If you put these switched around, I'll mark it wrong because nothing like that exists anywhere in nature or in the real world. What's my R group? 4 carbons. Do you break carbon-carbon single bonds? No. 1, 2, 3, 4. I'm going to replace the halogen with magnesium, then with the halogen, in this case chlorine. And that's how you do it. And since I didn't give you any in the problem set, let's do one more. And the question would be, what's the starting material to react with magnesium to make that compound? And this involves one of my great heroes in organic chemistry, Victor Grignard, a great French organic chemist. And good news this week, we're not dealing with any super hazardous chemicals in the lab. All right, let's take a look at this. Question is, what's the starting material? To react with magnesium to make this, what's different? Ooh, magnesium halide on a carbon. What do we react with magnesium to make that? Rx. In this case, X, remember, is the halogens, chlorine, bromine, or iodine. It's iodine. What's my R group? That. And therefore, right here, I will have a ring. Since I don't break carbon-carbon single bonds, I'll have my methyl groups. The carbon with the magnesium halide will be the carbon with the halogen, in this case iodine. And that's how you make a Grignard reagent. Now that we've got it, what can we do with it? We can have some fun, and we can make carbon-carbon single bonds. One of the things I noticed from processing videotapes, I do this a lot. I'll come up with some new arm and hand procedures. I'll work on that this weekend. All right. A, B, or C. Does anybody have a favorite?
B.
Which one?
B.
Which?
B.
B. That's a good one. Next one is, anybody have another favorite? No, I'll do it. Let's look at B. And the question is, give the organic product or products for the following. What's different here? Carbonyl. Double oxygen, double bond oxygen. Look for what's not a carbon or what's not a hydrogen. It's got hydrogen, methyl group, aldehyde. It could have been a ketone. What am I reacting with? Ooh, what's different? Magnesium halide and carbon, Grignard reagent. Second step, acid and water. What happens? You break the pi bond. What's ever attached to the carbonyl carbon is still attached to it. You open this up to an alcohol, and now the special thing is, to the carbonyl carbon, this R triple prime, you form a carbon-carbon single bond, and the carbon with the magnesium halide is the carbon bonded to the carbon with the hydroxyl group. Therefore, draw this first. What's attached to it? Methyl hydrogen. hydroxyl group. And then 2 carbons, that carbon, and that's how you do it. And now if you look to C, I've done the same thing. In this case, ketone, made it a little more complex, but if you know how to look at these problems, which you are learning that, it's not. What's different? Oxygen, double bond to carbon, carbon's here, ketone. What do we have here? Magnesium halide on carbon, Grignard reagent. What happens? What's ever attached to this carbon is still attached. My ring, it has a hydroxyl group. And then my R triple prime from the Grignard, the center carbon is bonded to the carbonyl carbon, which is now this carbon, and that's what you get. And I think, realistically, I would be extremely challenged, really challenged, how do I make this molecule without using a Grignard reagent? It would be quite hard. With a Grignard reagent, simple. And then the last page, D, E, or F, was F the one I made the mistake?
Yeah.
Let's go through and do F. I'm going to look ashamed. And on test, keep it a secret, this is my gift to you. And how is it a gift? Remember, what happens in 3301 stays now. I'm videotaping. What's that joke? All right, what's different? Well, first of all, the hydrogen 2 fell off there, but it's back on. Same thing over there. Same molecule. What's this? Carbonyl. Hydrogen, carbons, aldehyde. Same aldehyde. What are we reacting it with? Sodium hydroxide, and the problem said, I forgot to put water down in the test, I won't. And what happens? The alpha carbon is acidic. You pull off a hydrogen, form the enolate anion, a negative charge, which immediately attacks the carbonyl carbon, opens it up to an alcohol, and what you get is this aldol, OL, alcohol, aldehyde. The alpha carbon of one of the aldehydes attacks the carbonyl carbon of the other one. What's ever attached to it is still attached to it. This is one of those special ways of making a carbon-carbon single bond. Now, let's see. Here's my first aldehyde. What's my R group? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Methyl group, alpha carbon. Goes to the second one. 1, 2, 3, 4, 5, 6, 7. And this should not be there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My methyl group is right here. And that's the mistake I made, right? Well, 2-in-1 problem set. I'm calling it a day. No, I'm not. I once said that, and the class started putting their stuff away, and no. And that's how you do it. And let's go back and have fun with E. Because now we're getting into when we can do fun stuff in organic chemistry. And here, oh, benzene ring, that's different. Benzene ring. Does that react with sodium hydroxide and water? No. Ooh, aldehyde. Same aldehyde. Will that react? Yes. There's my alpha carbon right there, attached to carbonyl. There's my first aldehyde, take off a hydrogen. Alpha carbon, enolate anion, attacks the carbonyl. The second one forms an alcohol that's ever attached here. The benzyl group, CH2 benzene ring, and the hydrogen is still attached there. And that's how you do that. Anybody have any questions? Yes,
Can you go back to F and kind of like maybe zoom it in more?
hold on. And then I gotta get new hearing aids.
Can you go back to F so I can see which one you crossed off?
And the answer to that is, of course. Am I good or am I good? Perfect alignment. The carbon CH2 right next to the C with the hydroxyl group, just cross it off. Is that better? All right, any other questions on the aldehyde or ketone problem set? Well, in that case, you people look like you could use a pick-me-up. I think it's time once again to play that fun game, circle and name the functional groups. Brought to you by your host, Dr. White. And remember that fun game, how do you play that? You circle and name the functional group. And why don't you try that fun game, circle and name the functional groups. So much fun, it's guaranteed to put a smile on your face or your money back. No, I don't know about the money back. Time flies when you're having fun with aldehydes and ketones. this? Question is, circle and name the functional groups. How do you do that? You first look for what's not carbon, what's not hydrogen, or what's not a carbon-carbon single bond. Ooh, oxygen on a carbon. And this is an alcohol. Ooh, oxygen here, carbon here. They could be the same, they could be different. This is an ether. Ooh, a ring, but that's not a function. Ooh, carbon with the hydroxyl group again. That's an alcohol. Let's go to B. We look for what's different. Ooh, carbon, hydroxyl group on a carbon, another alcohol. Carbon, double bond to oxygen, carbons here and here. They can be the same or different. Ketone. Remember, ketone is not spelled with no Y, even though it's pronounced that way. Am I done? Oh no, another oxygen here. Carbons, carbons, ether. Oh no, one more oxygen, carbons, carbonyl, hydrogen, carbons. Aldehyde. And that's how you play your favorite game, circle and name the functional groups. By the way, this is not organic chemistry. Anybody come walking in the building and see they really do a good job around your maintenance, and I'm grateful for them. They had salt down there, so you wouldn't slip if there was any ice because it melted that. That's the colligative effect also you learned about, the melting points. It lowers the melting point. With that, I'm going to let you out a whole 2 minutes early so you can go out and fight the bad weather. Let's not that ready. Remember, tomorrow I will do a review for test number 2.